In Chapter 2, we talked a little bit about assigning integers to doubles and doubles to integers in some cases where they give a compiler error, some places where they allow it but gives unexpected results. Sometimes, however, you may actually want to assign maybe a double value or a decimal value to an integer, and you want the compiler to let you do it. So to do that, you do something called casting. Casting forces a variable to be another type. So we can look at this. We have inch declared as an integer, and there it is, 100 inches. Centimeters declared as a double. Now remember, the compiler will let you do this. Even though 300 is an integer, it will let you assign it to a double. Again, it's not the best practice because it's better for you to keep in mind that it really is a decimal, so you should put the decimal point in there. However, it still lets you do it. There's no change in value. Okay, now here, remember what final means? Final means that there's no way this will ever be changed. If I'm talking about this value, somebody could come along and another programmer could come along and change this value. In this case, well, I suppose you could change it in the definition, but when you're actually using it, you cannot assign other values to it. So this is always the conversion value. So again, that's what final meant. We talked about that previously. So now, what I want to do is find out how many inches are in a certain number of centimeters. I'm going to divide by the conversion factor. So when I do this, if I try this, I'm trying to assign to an integer, inch is an integer, I'm trying to assign what will turn out to be a decimal value. And again, the compiler will give the error because it knows you're going to lose decimal places. It knows that even if you really wanted to do that, it's going to be a problem, data will be lost. If you really did want to do that anyway, and you want the compiler to be forced to allow it, all you have to do is you still do the division here, and it's put in parentheses so that I'll do this first, and I'll get a value. I'll get some number, some decimal number. Then this little int keyword in parentheses forces the value over here to be converted to an int, and then the compiler will allow it to be assigned to an integer variable inch. So that's called casting. It changes the type kind of on the fly. Okay, so we've looked at something like this before. Pi, has decimal places in it, so we declare it as a double. If I do this, if I didn't have this int cast here, I couldn't really do this statement because the compiler would kick it out. It would say, yeah, you're obviously going to get x equal to 3, and you're losing all these pi decimal places, so it's probably not what you wanted to do, so it flags it. However, if I put the casting here, if I cast pi into an int first, it'll turn pi into just 3. Remember, it truncates. It doesn't round up or down. Actually, it rounds down. That's truncating. So pi will become 3, and I'm allowed to assign it to x. In this case, same idea. This is a double. I'm doing pi times 20. 20 is an integer. If pi is cast to an integer, now this cast didn't cast pi times 20, it's just casting pi into an integer. So pi will become 3, 3 times 20 is 60, and it'll assign it to the double. You'll still lose the decimal places because this division was done as an integer division. In this case, I do pi times 20. This case, I'm doing 3.141592 times 20 because pi is not an integer here. So I get a value, I cast that to an int. In this case, y will be assigned the value 62 because 62 point and some decimal places is equivalent to the value of pi times 20. Okay, we'll look at that when we look at the coding part. We'll look at some examples of what happens. Okay, there's an operator called the modulus operator. It's the percent sign. It's basically the remainder after division. Now, it seems kind of like a strange thing to want to ever do, but it's used. There are actually a lot of uses for it, but it's very commonly used in encryption algorithms. We should be able to get to look at a few of the very simple ones, but like a rotational, maybe a rotational encryption. We'll look at those later in the course, but basically all it does is does the division and then gives you whatever the remainder is. So I do, for example, I have quotient as an integer. I do 72 divided by 12. I should get the correct answer, quotient equal to 6. 72 divided by 12 is 6. No decimal places to lose. If I do 72% 12, I should get 0 because 72 divided by 12 should be 6.0. So all it does is takes out the remainder and assigns it. In the book, it mentions something called a scanner bug. excuse me, that's in section 3.10. It's not really a bug. It's just that you have to understand exactly how the methods within Scanner or the classes within Scanner work. So they talk about next line versus next int. Remember, when you do a next line, that reads in no matter what you have up until it hits a new line, a /n, or that's what it would interpret as a /n. So it reads anything. If you have integers there, it'll read it. If you have alphanumeric there, it'll read it. If you just have letters there or alphabetic characters there, it'll read it up until the point it hits a new line. But next int reads, it starts where it currently is, and it reads up until it finds the first character that's not an integer or not a number, not a digit. So if it hits a new line, it'll stop. If it hits a decimal point, it'll stop it. If it hits a letter, it'll stop. However, next line just keeps reading until it hits a new line, no matter what's in there. So I'll explain what they mean by that scanner bug when we look at the code in a minute. Now we're going to take a look at the program that converts centimeters to feet and inches, and it does some casting. So the first thing to notice is that it imports the scanner class because it uses it to input. So there's public class convert. There's the main as usual. So in this case, I have a centimeters in double, but inches, feet, and the remainder, which we'll look at. The remainder is just an integer. So all this we've seen before. Okay, so here is where I create my scanner. And let's see, here's where I create my scanner. So first I have to prompt the user to tell me how many centimeters I'm talking about. Otherwise, it won't know why the program is just sitting there hanging, waiting. So I prompt the user. Then I take the scanner that I just created, look for the next double. So this time I'm looking for a decimal value, so it'll read numbers and 1 decimal point and keep reading numbers until it hits something that's not a number or not a digit. Assigned it to centimeter, that'll work correctly because it's a double. Okay, then it does the conversion. Remember, this conversion could be a problem if I'm assigning to inches because inches is an integer. However, the compiler won't give me an error because I cast it as an int. Okay, so let's see what happens when we run this program. By the way, we've already looked at this. We've already looked at the formatting. That's from the previous slide. This one, what's happening here, just so let's go over this before we run it. This will give the remainder after division by 12. There's 12 inches per foot. That tells you how many inches. You figure out feet, and then the remainder is actually how many inches are left over. So here's an example of the modulus operator where that's a useful application of it. Okay, so let's run it and see what happens. Okay, so it's prompting me for how many centimeters. Let's say, I don't know, let's give 50 centimeters and see what happens. So 50 centimeters equals 1 foot, 7 inches. So the casting worked, everything worked correctly. Now this program is an example of what they called in the book the scanner bug, but again, it's really not a bug. It's just the subtleties of how the next line and next int functions work or methods work from the input class. Okay, so again, the first thing is java.util.scanner. You got to input that because it's not a standard part of the language. I allocate my new scanner. I call it in. So again, I'm going to first prompt the user because otherwise it won't know what I want to do. Ask the user what's their name, they'll type in some characters. Next line should read up to the next new line. No matter what you type in, numbers, letters, whatever, it's just going to read up to the next new line. When you type in what your age is, it's prompting you for age. When you type in that, it's expecting numbers. So it'll keep reading whatever numbers you type in until it comes to something that's not a number. And probably the first thing it'll come to that's not a number will probably be the new line. And that's what gets you into trouble when you do things in the opposite order. So the first one should work correctly. The second time when you ask for the age first, this will read, remember it's going to read numbers up until it hits the first thing that's not a digit. So that should usually be the new line. So then when it goes to read the name here, it's the pointer to where it's looking at in the input stream is really pointing to the new line. It didn't really get past it yet. It's just pointing to it. It read the digits, the integer that you typed in, and now it's pointing at the new line. So when you do the next line right here, you're expecting it to be your name, but when it goes to read the next line, remember that input stream pointer is pointing to the new line that was right after the integer. So when it goes to read name, it's going to come back with nothing. So you'll see that's Sounds like a bug, but it's not really, just a subtlety of how it works. So let's see what happens. Okay, so when I run it, okay, first thing it asks is my name. Okay, new line, what is my age? Okay, so it printed out correctly. It got my name, it got my age correctly. Now the second one, what is your age? It wants my age first. Remember, it's going to read numbers until it hits a new line. It's the new line. Now what happened here is it didn't get anything from my name. My name is basically a null because when it went to read the name up here, remember the input stream is pointing at a new line. So as soon as it hits that new line, basically next line is done because it hit a new line. So it read in basically no characters to put them into name. There were no characters to be found. It just found the new line. The next line was a null line. That's why we had this input.